All right, this video, we're going to talk about adding vectors using what's called components. And this is where we left off, was on page 4 using scale models, but we're going to skip this for right now because we need to be able to use protractors and we can't share them with COVID going on. So we're going to skip this part and we may come back to it later. But we're going to jump to here on page 5, finding the components of vectors. Now the word components means parts. Okay, so components. So the components of vector are its parts, and the components must add to form the vector. So if I draw the vectors tip to tail, they should end up with the vector that I start with. So here's vector z, and I want to find its components, its parts. So if I took two vectors, a, b, they're tip to tail, so the result is here. So z is the sum of a plus b, excuse me. So we could say z. And they use this little arrow symbol over the top to represent vectors. So vector z is equal to vector a plus vector b. So we would say a and b are components of z. Now it turns out there's an infinite number of ways I could do this. I could go this way, call that c and d, and I could say vector z is made up of c plus d. And I could even do a 3-vector system, say E plus F plus G, and I would say vector Z is equal to E plus F plus G. So how many sets of components are there for any vector? It's infinite. So what good is it? And it turns out that there are two components that are going to be very, very useful. And that's the horizontal, or the x component, and the vertical component. So here's A, all right? And I'm going to draw in a horizontal component, and you just draw it over till it's right below the tip of it, like this. And components have to be vectors, so they have to have arrowheads on them. I'm going to label this guy AX. And then I'm going to go straight up here, and that's going to be AY. Remember, components are vectors. So you have to draw them as arrows. I can't just draw a line there and a line there. I have to have an arrow. And they have to point the right way. Since A is up and left, AX is to the left, and AY is up. Okay, now we have to find the size of those. Oh, sorry. So we have an example of that on the top of the next page. And this example says for the problems below, we're going to find the horizontal and vertical components. So here's A this way. So I'm going to draw in AX. So I go till I'm right below the point there. And then AY up here. Then I'm going to use some trig to find the size of these. So this one here is the adjacent, this is the opposite, and this is the hypotenuse. It's kind of backwards what we were doing before. Before we had these two sides and we wanted to find the hypotenuse. This time we have the hypotenuse, we want to find those two sides. So again, if your trig is rusty and you have to write down SOHCAHTOA every time, it's okay. If I'm trying to find AX, that's the adjacent side, and my given is the hypotenuse. So for X, I'm going to use cosine, because cosine is adjacent hypotenuse. So cosine theta, again, I'm showing all the detail out. This time, I won't continue to do that, and you don't need to show all the detail either. But if it helps you to do so, do so. So cosine of 30 is equal to, the adjacent side is AX, and the hypotenuse is 60. Multiply both sides by 60, and I get 60 cos 30 is equal to AX. When I plug that in my calculator, I get AX is equal to 52.0. So there's AX. Now for AY, I'm going to split this up here. I have opposite, I have hypotenuse, so I'm going to use sine. So I'm going to skip a couple steps here. I'm just going to say sine of 30 is equal to AY over 60. Cross multiply, AY is 60 sine 30. And when I plug that in my calculator, I get 30. So there are my two components. AX is 52. I can write them in here. And AY is 30. And if you wanted to check it, you could do 52 squared plus 30 squared. Square root of that is going to give you 60. Now for B, I'm going to draw them in. And I'll draw BX over here and BY up here. Okay, here's my adjacent. Here's my opposite. Here's my hypotenuse. Okay, so I'm going to kind of skip some steps, but I know that for the adjacent side, since I have the hypotenuse, adjacent hypotenuse is cosine, so COTOA, right? Cosine is adjacent over hypotenuse. So cosine of 30 is equal to the adjacent over the hypotenuse. Bx is 60 cos 30. Bx is equal to, put that in my calculator, I get 52.0. All right, I'm going to need some space for this here. All right, by, it's the opposite side, and I have the hypotenuse. I'm going to skip all the way to here, and you can do this as well if it's working for you. This is going to be 60 sine 30. So by is 30. Now, you may have noticed that these are the exact same numbers. Why would I give you this problem with the same numbers? It's not because Mr. Lynch is going senile, all right? It's because I wanted to make a point here, okay? These two vectors, imagine they're force vectors. They're going to have a completely different effect on me, right? If I'm being pulled up and right by a force of 60, that's when I'm going to move. B would make me move the opposite way. So these are different vectors. There has to be something different about their components. And what we've done so far is AX and BX are the same, AY and BRY are the same. How are we going to make them different? And it turns out you have to watch the sign, okay, positive or negative sign, not sine cosine, of the components. Okay, left and down are negative. Okay. So on the other side, I made a point of saying this is up and right, so this has to be right, this has to be up. This is up and left, this has to be left, this has to be up. Okay, and since this one's left, this one is going to be negative 52. Negative because it points left. Now our last one over here is C, and you kind of get used to drawing these triangles, and then you have one that's straight down and you get confused. You try, maybe making a triangle for it or whatever, but in this you don't have to, right? And if I was to look at this C is all pointing straight down, okay? It's all vertical. How much of it's horizontal? How much of it is in the X direction? If all 40 is in the vertical direction, none of it is in the horizontal direction. If it's all Y, there's no X. And then all of it, the whole 40, is in the Y direction. Whoa, be careful. You don't miss something, right? This is pointing down, so it has to be negative. All right. Now, adding vectors using components. All right. And again, the steps may not make a whole lot of sense until we do one. The first step is to find the X and Y components of all the vectors. The second step is to find the components of the resultants by adding the individual components. So once we know AX and BX, we add those up to get RX. AY and BY, we add those up to get RY. And then we construct the vector R using the RX and the RY. So step one. All right. Now we have two vectors here. We got 20 newtons east. I'm going to call that, say, vector A. And 30 newtons, 40 degrees north of east. I'm going to call that vector B. And actually, kind of before we even get to step one, I'm just going to sketch this just to see what it's going to look like. So I got 20 newtons east. And then I got this one. And I'm going to draw it tip to tail right away so I don't have to move it. And I got 30 newtons, and 40 degrees. So my resultant ought to end up looking something like this. All right, so we're just going to check that. That's going to be our check, see if we end up with something like that. So it's got to be bigger than 20, bigger than 30, but less than 50, because if they were in a straight line, it'd be 50. So step one. Step one is find the x and y components of all the vectors. So I'm going to draw these separately just because it makes my life easier. So A here is 20 newtons, and B is 30 newtons, 40 degrees north of east. Okay, there's my reference. So my reference is east, and I swing 40 degrees north of that. Now for this one, AX, all of vector A is in the x direction, so all 20 is in the x direction, and none of it is in the y direction. Now, I always say stop and think about it for a minute. I got to look at my signs. If that's pointing to the right, I'm going to make it positive, so AX is still going to be positive. Now for B. B is 30 newtons this way. We'll draw in BX here and BY there. Here's my adjacent, here's my opposite, here's my hypotenuse. All right. X is the adjacent, and I have the hypotenuse, so that's going to be cosine. So cosine of my angle is going to be adjacent over my hypotenuse. BX is going to be 30 cosine 40. And that's going to give me a value of 23 when I plug in my calculator. And then BY is going to be, and I'm just going to skip ahead, it's going to be 30 sine 40. And again, you can skip ahead like that if this is making sense. If you need to do the whole SOHCAHTOA thing, go ahead. And when I calculate it, I get BY is equal to 19.3. So there's that value. All right, so here are my 4 components. Now, remember, we should check and see if anything should be negative. BX is to the right, so it should be positive. BY is up, so it should be positive. I probably should have, in the example, had at least one that's negative, but I didn't. So that's step 1. Step 1 was find the x and y components of everybody. We have that. Step 2. Rx is equal to AX plus BX. And if we had a third one, we could say plus CX and so on. AX is 20. BX is 23. So my Rx is 43. My Ry is AY plus BY. AY is 0. And BY is, where is it, 19.3. So then Ry is going to equal 19.3. So the first step was find all of the components. Second step, add the x components and add the y components. And our step 3 is to make R from those two. Well, Rx is positive 43, so I just make an origin. And I always go the x direction first. And it's positive 43, so I would go that way, 43. And then Ry is positive, so I'm going to go up from there for that one. Again, I probably should have made something be negative, so if Ry was negative, I'd have gone down. Then I just draw in my resultant from the origin to the tip of the last vector I drew, and I would just have to find R and theta. So R squared is 19.3 squared plus 43 squared. So if I square them and add them up and take the square root, I get R as 47.1 newtons. Okay, going back, I'm going to put my unit on that. And then to get this, I have the opposite and the adjacent. So I'm going to use tangent. Tangent of my angle is equal to 19.3 over 43. So I would divide that out and then do inverse tangent. And I get theta is 24.2 degrees. Now up here, I drew this as kind of a check. And remember we said it's going to be, more than 20 and 30, but less than 50. and we got 47.1. That makes sense. And the angle here, 24.2, makes sense because it's less than the 40.